algebra, we are moving ahead with rule number 3 of 5, CO12. And this rule, the objective is I can simplify an expression with a zero exponent because this rule only applies when a base's exponent is 0. Okay, a base's exponent is 0. And we're actually going to start with the rule today, and then we're going to look at why it works. Okay, no real expanded form for this just because the power is 0. It's a little bit different situation. So when a base has a 0 exponent, the coefficient, is the coefficient affected by the exponent?
No.
It is not. So in this rule, the coefficient stays the same. Okay? The coefficient stays the same. And the base with that 0 power, the base becomes a 1. We're going to explain that. Okay? The base becomes a 1. Right? So, for example, we'll do a couple of examples here. If your base is a number, if it's 19 to the 0 power, 19 to the 0 power equals 1. No, 1. The base becomes a 1. Okay? 19 to the 0 power equals 1. If your base is a variable, if you're taking n to the 0 power, n to the 0 power equals 1. Okay? The base becomes a 1. If you do have a coefficient, such as 3y to the 0 power, read the rule.
3.
James?
3, 1.
3, like 31?
No. It's just 3. Just 3.
Just 3, right? Just 3.
I don't get it.
The y to the 0 power becomes a 1, right? That base, the base of y becomes a 1, and 3 times 1 equals 3. So the rule in a nutshell is that any base to the 0 power is 1. Right? Is 1. Any base to the 0 power equals 1. Now, let's explain this a little bit. Right? Because there's some people saying that they don't understand it, which makes sense. This is kind of a confusing thing. How could this possibly be? Like, did someone just decide, oh yeah, we'll just make anything to 0 power equal 1. Let's just teach them math. No, there's actual mathematical reasoning behind this. And let's look at the property of division here. Okay? What is anything divided by itself? 1. Right? So if we have x cubed over x cubed, even though we don't know what x equals, because it's something divided by itself, we know it has to equal 1.
Yes, guys.
Yes.
Anything divided by itself equals 1.
What about 0?
Okay? We're not going to go there. All right? This is already confusing enough. Okay? Can you all agree with me on that?
Yeah.
Like you've heard that property of division before, that anything divided by itself equals 1. Okay? Now let's go to what we learned in CO11. Right? If we have that same x cubed over x cubed, and we use our rule from CO11, where the powers are subtracted, what does this equal?
X.
To the what power?
0.
To the 0 power.
Wait. Yes, it says 0.
Right? Using our rule from CO11, which then stop just saying that and start listening, right? If we use our rule from CO11, we know that when we divide by the same base, which we are here.
Wait, we divided by the same base in the other one too.
Yes, hold on, just wait, just shh, okay? When we divide by the same base, our rule in CO11 says the powers are subtracted, right? So we can say that x cubed over x cubed is going to be x to the 0 because 3 minus 3 equals 0. That's what the rule says, right? Now, as someone just pointed out, in the previous piece here, we said that x cubed over x cubed is equal to 1.
But x0 is equal to 1.
If we have the same thing equal to two different things, what does that mean about x to the 0 and 1? They're also equal. They have to be. If x cubed over x cubed is equal to two different things, then they must be equal to each other. So if x cubed over x cubed is equal to 1, and x cubed over x cubed is also equal to x to the 0, therefore, x cubed, or I should say x to the 0, equals 1. Okay? And that goes for any base. Right? If you agree, if you understand how division works, that anything divided by itself is equal to 1, no matter what it is, and you also understand CO11, the rule being that we would subtract those powers, which means that this would equal x to the 0. If the same expression equals two different things, those two things must also be the same. Okay? In geometry, we call that the transitive property. Basically, if A equals B and A is also equal to C, then B is equal to C. Right? Whatever A is, if it's equal to B and C, those two things must also be equal. That's kind of what's going on. All right, pepper me with your questions, Evan. This is a key point, this whole piece here. So yes, that can go on a help sheet. Gus.
Okay, so 2 plus 4 times 2 can equal the same thing as 2 plus 4 times 2. That's why they made the order of operations.
Right.
Why didn't they say 12 and 10?
Yep.
12 and 10.
Yep.
Why don't they just say, well, 12 and 10 are equal?
Because in order to get 12 and 10 with 2 plus 4 times 2, right, that's said, as it's written, right, you would multiply first. 4 times 2 is 8, plus 2 would equal 10. As the second one is written, it's also equal to 10. If we want it to be 12, we have to change it, right? This is no longer the same thing here. So 10 is not equal to 12 because these two things are not the same. X cubed over x cubed is exactly the same expression.
2 plus 4 times 2 and 2 plus 4 times 2 aren't the same?
But do you see the parentheses there? That's different.
Wait, what?
Right? This expression is not the same as what we have there. This one's got parentheses, that one doesn't.
Yeah, to get x over 0, you have to do differently. You have to subtract the exponents.
Yes, which is legal, right? Yeah, that's a way to solve it. I didn't change anything with what this says. I didn't add parentheses. I just changed the method. I just did something differently. I followed a mathematical rule that says when you divide by the same base, the powers are subtracted. Right? And then I also said, well, I know that a division property is that something divided by itself equals 1. I didn't change anything. That's a mathematical rule. And because using those two methods, which are mathematically legit, I get two different answers, that must mean that these two things are equal to each other. Okay? It is a little bit tricky to wrap your head around. Like I said, this seems like it's the easiest rule on paper because it's just any base of 0 power is 1. Oh, okay, great. But sometimes that easiness leads to complacency because it is a difficult rule to wrap your head around because it's new math.
Okay.
For everybody. Okay? All right. Any other questions?
Nope.
Then let's go
Where?
to the homework. Simplify each expression. N to the 0. We have a base of n to the 0 power. What is it equal to? 1. We had that as an example up above. Okay? X to the 0, y to the 0.
1, 2, 11.
2.
So this base of
1
x.
times 1 equals 1.
Yes. This base of x equals. This base of x to the 0 equals 1. This base of y to the 0 equals 1. And what operation is in between them?
Multiplication.
We're multiplying, right? And so 1 times 1 equals 1. Okay? 3,481 to the 0 power. 1. That 3,481 is a base. The power is attached to it. It is equal to 1.
Seven.
7y to the 0 power.
7.
7. That coefficient is not affected by the power, so that just kind of tags along. But y to the 0 equals 1. And 7 times 1 equals 7.
What about the fifth one or the sixth one? What's the
Neg-
negative 9.
If 3 people are asking you to do 3 different questions, that's not very conducive. Negative 9 to the 0 power.
Negative 9.
It has a coefficient. Negative 9, not affected by the power. N to the 0 becomes a 1. Our answer is negative 9. Negative 9 times 1. That last one there, my little tidbit, it says if you see a base with a 0 power in an expression, like this y to the 0 is part of an expression, it's not just like n to the 0 or x to the y, it's part of something else, cross it out and ignore it. Because what is this equal to again? 1. This is the same thing as saying x cubed times 1 times z squared. Well, what's x cubed times 1 times z squared?
X3.
Just x cubed times z squared, right? If you multiply something by 1, it doesn't change the value. So x cubed times 1 is just going to stay x cubed, and then you multiply by z squared. So in this case, it's kind of smashed in with other stuff. I just ignore it because it really doesn't matter at all. It doesn't do anything. This would be the same thing as saying, I've got x cubed times y to the 0 times z squared. And hey, I have no b's either, or c's, or h's, right? I can write stuff to the 0 all day long. It means I've got none of them. Times 1 times 1 times 1. It all doesn't matter. Okay? Just eliminate them. They all equal 1. Same thing with the next one there. 18n to the 0 z squared. This is really just a 1. Isn't 18 times 1 times z squared the same thing as just 18z squared? Yeah. Multiplied by 1 doesn't do anything. So just ignore it. Okay? Yeah.
Can you do the last one in the second row?
You can do it.
The last one in the
Emily.
row.
Can you do the 2 and 0 z 0 over 6?
Do what you want.
You can do it.
I don't know how to do it.
Why not?
Do what?
Just cancel it out?
Sure. Isn't 2 times 1 times 1 is the same as 2? Because that n to the 0 is just a fancy way to write 1. The z to the 0 is a fancy way to write 1. So really it's just 2 times 1 times 1. And then put that in the simplest form. Because now we've got a fraction. Okay? So, any base to the 0 power equals 1. Where people get caught with this, one of two things. Either they think any base to 0 power is 0, so they just put 0 for all of them. Okay? Or whenever they see a 0 power, they always put 1. That's not the case. You have to pay attention to what's my base, what's my coefficient, how do these things interact with each other. Okay? This is due tomorrow. Give it a shot. I think you can do this. It's a 1-pager, and then tomorrow we get to dive into negative powers. How fun will that be? Negative powers. So, CO12 for homework for tomorrow. Hopefully you can get it done during class. Happy Halloween. That's how you math.
Don't forget to